Welcome to day 49 of the low-level design course. Today we are diving into requirement analysis and modeling, one of the most critical steps in designing any system. Whether you are building a small-scale application or a complex enterprise system, understanding how to accurately gather, analyze, and model requirements will set the foundation for success. By the end of today's session, you will be equipped with the skills to effectively capture the needs of your users, prioritize them, and translate them into a robust design model. Let's start by outlining today's goal. First, we will focus on understanding the process of requirement gathering, which is crucial to ensure we capture everything that the system needs to do. We will then explore how to analyze and prioritize these requirements efficiently, as not all requirements are equally important or urgent. Finally, we will turn these requirements into actionable models, including user stories, use case diagrams, and domain models, which will help us design systems that align with business goals and user needs. Requirement gathering is the cornerstone of any successful system design process. Simply put, it's about collecting the essential details regarding what the system needs to accomplish and how well it needs to perform. This includes understanding both functional requirements, which describe what the system must do, like allowing users to register, log in, or perform a transaction, and non functional requirements, which focus on how the system should behave under various conditions. For example, a non-functional requirement could be the system's performance, ensuring it can handle thousands of users at once. You will gather this information from various sources such as stakeholder interviews, product documentation, system analysis, and sometimes workshops. The goal here is to leave no stone unturned and ensure you have a clear picture of what the system should achieve. Let's break down the two major categories of requirements. Functional requirements are the heart of what the system needs to do. These could be actions that users perform, like place an order or update profile. Think of functional requirements as the specific features and behaviors of the system that will satisfy the user's needs. On the other hand, non-functional requirements define how the system should perform under certain conditions. These requirements include things like security, scalability, availability, and performance. For instance, a non-functional requirement might be something like the system must handle 10,000 transactions per minute without downtime. These non-functional requirements are just as important as functional ones because they ensure the system runs effectively, efficiently, and securely under real-world conditions. Now that we understand the types of requirements, let's focus on how to analyze them effectively. The first technique is to clarify assumptions. Requirements often come with a lot of implicit assumptions, and it's essential to confirm these with stakeholders. For example, is there an assumption that the system will be used only in a specific geographic location, or should it support users from multiple time zones? Next, you will want to prioritize your requirements. Not all requirements are created equal. The Moscow technique is one of the most popular methods for this. It divides requirements into four categories: must have, should have, could have, and won't have. By prioritizing this way, you ensure that you focus on the most critical aspects first. Another critical aspect is to resolve conflicts early. During requirement gathering, you may encounter conflicting requirements. For example, one stakeholder might want a feature that requires high speed performance, while another wants a more feature rich system that requires more processing power. It's important to bring these conflicts to light and resolve them before moving forward. Lastly, always validate your requirements with stakeholders. Requirements are dynamic, and as you progress, things may change. Regular validation ensures you are building the right thing and meeting user expectations. Once you have gathered and prioritized your requirements, it's time to translate them into use cases. A use case describes how an actor, which can be an user or another system, interacts with the system to achieve a goal. Use case diagrams help visualize these interactions, making it easier for stakeholders to understand the flow of events. For example, consider the use case user registration. The actor here is the user, and the goal is to successfully create an account. Use cases also include different scenarios, such as a user entering incorrect data or the system failing to process the request. These variations help identify edge cases and ensure that your system handles a wide range of scenarios. You will also need to define the relationships between actors and use cases using terms like include, extend, and generalize. This helps capture more complex interactions and ensures all possible paths are covered. Another valuable tool for requirement analysis is the user story. User stories are short, simple descriptions of features told from the perspective of the user. The standard format is, as a user, I want feature so that benefit. This format keeps the focus on delivering value to the user. For example, as a shopkeeper, I want to deliver products by category so that I can find what I am looking for more quickly. One important principle to follow when writing user stories is the invest principle. Each story should be independent, negotiable, valuable, estimable, small, and testable. This ensures that each user story can stand on its own, is clear and easy to implement, and can be tested effectively. Now let's discuss domain modeling. A domain model is a high-level abstract representation of systems, codes, entities, their attributes, and how they interact. Think of it as a blueprint of your system's major components. For example, in an e-commerce system, some core entities might include user, order, product, and payment. These entities will have relationships with one another. For instance, a user can have multiple orders, and each order contains multiple products. Domain models help you map out the system's main building blocks without getting into technical implementation details. It's an essential step in translating abstract requirements into concrete logical structures. In a domain model, the primary elements are entities. These are the key objects in the system that represent real world concepts. For instance, in a library system, book and member are entities. Relationships. These define how entities interact with each other. They can be association, aggregations, or compositions, each with different implications for the system. For example, a member may borrow many books, but each book can only belong to one member at a time. Attributes. These are the properties of the entities, such as the name or ISBN for a book. Behaviors. These are the actions or operations that an entity can perform, such as a place order operation for a user. These elements come together to give you a clear responsibility of the system's domain, which is a crucial reference when you begin designing the system in greater detail. Now it's your turn for to apply what we have discussed. For today's hands-on activity, you will work on a capstone project. First, draft 5 to 7 user stories that define the main features of your system. Think about your users. Who are they? What do they want? And why is it important? Next, create a use case diagram to visualize your users, how they interact with the system. Identify the key actors and their goals, and draw out the system's interactions. Finally, take a shot at sketching your first domain model. Identify the core entities of your system and the relationships between them. Don't worry if it's rough. The goal is to start visualizing the system at a high level. As you move forward with requirements analysis, keep these best practices in mind. Focus on the what, not the how. At this stage, you are not worried about technical details. You are focused on understanding the user's needs. Capture edge cases early. Think about the less common scenarios, such as what happens if a user enters invalid data or tries to perform an action they are not authorized to do. Document everything. The more you document, the clearer your design will be down the line. Keep models interactive. Requirements and models evolve over time, so don't try to be perfect everything upfront. Start simple and iterate as you go. Version your requirements. As requirements change, make sure to keep track of the versions so you can reference them later if needed. Let's recap the key takeaways from today's session. Requirements gathering is an iterative and dynamic process that lays the foundation for everything that follows in system design. Clear, actionable models like use cases, user stories, and domain models are essential for translating abstract requirements into a concrete design. Effective analysis, prioritization, and validation of requirements lead to better system designs and reduce the risk of rework later in the development process. Before our next session, take some time to review the basics of UML diagrams as we will be diving deeper into them. Also familiarize yourself with the interface segregation principle ISP and the list scope substitution principle LSP. These principles will be crucial as we move into more detailed design and implementation phases. Looking forward to seeing how you apply these concepts in your projects. Thank you for your attention.